Hello dear students, welcome to a new video from IGCSE with Optimus. In today's video, we are going to solve AS level structured questions paper code 21 from May-June 2025 series. You can see the paper on your screen. The first question in the paper says define acceleration. So our answer should be acceleration is rate of change of velocity. That is change in velocity upon time. The next question says in an experiment, two objects A and B are released from the side of a building as shown in figure. Object A is released from rest at height of 14 meter above the horizontal ground. Object B is released with an initial upward velocity u at height of 3.6 meter above the ground. Both the objects take the same time to reach the ground and they do not collide with each other. The air resistance is negligible. The first question is calculate the time taken for the object A to reach the ground. Now see that object A is covering the total distance of 14 meter when it is released from the height that is mentioned as 14 meter. So the displacement of object A is going to be 14 meter. We can use formula S equals to ut plus half gt square, where g is acceleration due to gravity. Since initial speed is 0, this entire term u into t will be 0 and S will be equal to half gt square. Now to calculate t, we can write it as 2 times of S divided by g. That will be 2 into 14 upon value of g, that is 9.81. This gives us answer 1.68. We can write it as 1.7 seconds. Note that 1.7 second is the same time taken by object B as well from its starting point until it reaches ground. The next question is use your answer in B1 to calculate u. U is the initial speed with which object B is projected upward. Now object B is projected upward and then it reaches ground. It covers the displacement of 3.6 meter in the opposite direction of the speed that we had given initially, which was upward. So the displacement of this object is going to be minus 3.6 meter. Also note that since the object is going upward, it's going against gravity. So we can take g also as negative. Our overall formula will be S equals to ut plus half gt square, and considering the signs, it will be minus S equals to minus half gt square. So S will be minus 3.6, u is what we are supposed to find out. The time is 1.7 minus half 9.81 into 1.7 square. So it will be minus 3.6 plus half into 9.81 into 1.7 the whole square is equal to u into 1.7. So u will be equal to 6.22. So we can write it in 2SF as 6.2 meter per second. The next question, in second experiment, object B is released from the same height and given the same initial speed as in B, but at a release angle theta to the vertical as shown in figure. State and explain whether the time taken for object B to reach the ground is less than, the same as, or greater than the time in B1. Now you can understand that since the object is given with velocity at angle, its vertical component of velocity is going to be u cos theta, and u cos theta is going to be lesser than u. Okay, so the initial vertical velocity of object decreases hence the object takes lesser time to reach ground because it is also going to achieve lesser height. Next question, by considering energy, state and explain the effect of the change in release angle on the speed at which B reaches the ground. Note that here they are asking about speed, not velocity, and energy is a scalar quantity. So the changes in energy are going to be same even if the object is projected at angle. So we can write no change in the speed because the change in kinetic energy and gravitational potential energy of the ball will be same. This is as per law of conservation of energy, that the energy will always be conserved. Question number 2, it says that state the principle of moments. So we can write in equilibrium state of body, the sum of clockwise moments is equal to the sum of anti-clockwise moments. Question B, it says 3 objects A, B and C are placed on horizontal beam. The beam is in equilibrium as shown in figure. The beam is uniform and has length of 6 meter. Okay, so since it is uniform, its center of gravity will be at its geometric center. So you can understand this distance is going to be 3 meter. Same way, even this distance is going to be 3 meter. Object A has mass 60 kg, object B has mass 45 kg and object C has mass 80 kg. Now note that they have given us masses, not the weights of the object, but in calculation we have to consider weights because the principle of moments applies to the forces, not the masses. So in this direction we will be having weight of A acting as 60 times 9.81, weight of B acting here, that is 45 times 9.81, and weight of C will be acting in this direction, that is 80 times 9.81. Now the question is to calculate X. We can write the formula that total clockwise moment is equal to total anti-clockwise moment. Now you can note that force from C will produce clockwise moment here, and these two, that is force from A and force from B, are going to produce anti-clockwise moment. So for clockwise moment we can write 80 times 9.81 multiplied by its distance from pivot, that is 3 meter, is equal to total anti-clockwise will be the force from A and its moment, that is 60 times 9.81 times 3 plus for B it will be 45 times 9.81 times X. So X will be 2354.4, that is for the total clockwise moment, minus 1765.8, which is anti-clockwise moment from A, and then divide this by 441.45. So the answer would be 1.3 meter. So the value of X here is 1.3 meter for the rod to be in equilibrium. Part C, the beam is 0.80 meter above the horizontal ground. Object A is removed and replaced by spring connected to the ground and the beam as shown in figure. After the change, the beam is again horizontal and it is in equilibrium. Meaning, even the spring is helping the beam to be in equilibrium. It is producing the exact same moment as it was produced by A earlier. The position of B and C are unchanged. The spring has unstretched length of 0.59 meter and it obeys Hooke's law. Calculate the spring constant of the spring. So we can write that force on spring is equal to force from A that was produced here, okay, that is 60 times 9.81. It is 588.6 Newton. Now K is equal to F upon X. Force is 588.6 upon X. Now to calculate X, what we need to understand is the total length of the spring when it is balancing the rod, that is 0.8 meter and its original length is 0.59 meter. So 0.8 minus 0.59 will give us the extension in the spring. So 588.6 divided by 0.8 minus 0.59 gives us answer 2802. So we can write it as 2800 Newton per meter. The next question they are asking is calculate elastic potential energy of the spring. We know the formula for elastic potential energy, that is half into K x square. So it will be half into 2800 into 0.8 minus 0.59 the whole square. The answer comes here is 61.74. So we can write it in 2SF as 62 joules. Next, question number 3, it says define power. So we can write the formula for power, the definition of power as rate at which energy is transferred. So power is equal to energy divided by time. Question B, it says an electric car is powered by a motor. The car is traveling at constant speed of 35 meter per second. Note that whenever they say that the car is moving at constant speed or any object moving at constant speed, it means the forward force acting on the car, which is from the engine, and the backward force, that is air resistance or friction, would balance off each other. And that's a key to solve this question. It is traveling along a straight horizontal road as shown in the figure. The total resistive force is 1750 Newton acting on the car. Calculate the power transmitted to the wheels of the car by the motor. Now we know the formula for power, that is force into velocity. Again, to repeat, here the force value will be taken as 1750 because in constant speed the backward force, that is resistive force, must be equal to the forward force produced by the engine. So this will be 1750 multiplied by 35. The answer comes 61,250. So we can write this as 6.1 into 10 raised to 4 watt. Calculate the useful work done by the motor when the car travels distance of 17 km. So for work done, we can use formula F into D, where force is going to be 1750 again into distance. Since it is given in kilometer, we have to write that in meter. So it will be 17,000 meters. This comes 2.97 into 10 raised to 7. So we can write it by rounding it off as 3.0 into 10 raised to 7. Always remember, whenever we write answer in standard form, the number that we write before the power of 10 is written in 1 dp. So here, instead of writing 3 into 10 raised to 7, I have written 3.0 into 10 raised to 7. Next, the potential difference across the motor has constant value of 600 volt and motor has efficiency of 85%. Calculate the current in the motor. So efficiency is output power upon input power into 100. So they are giving us efficiency as 85%. We already have the output power for the engine, which is calculated here, 6.1 into 10 raised to 4 watt. So 6.1 into 10 raised to 4 divided by, for power input, remember the formula for electric power, it is voltage into current. So we are writing it as 600 into I multiplied by 100. So I will be 6.1 divided by 10 raised to 4, 6.1 into 10 raised to 4 upon 85 into 600 into 100. The answer comes as 119.6. By rounding it off, we will write it as 120 ampere. Next question. The car in B now reaches a slope as shown in figure 3.2. The car continues down the slope at the same speed. Note that the car is going at same speed as in B. State and explain the effect, if any, of this slope on the air resistance acting on the car. Now we know air resistance is directly proportional to the speed of the car. If the speed would increase, air resistance would increase. In this case, they have said even if it is on the slope, the speed maintained by car is same. Okay, so the air resistance will be same. So we will write no change on air resistance as speed of the car remains same. And the next question is the current in the motor. Now understand that the car is on the slope. Because of this slope, the car is going to gain speed as gravitational potential energy will be converted into kinetic energy. Now the car is maintaining the same speed. So the engine power or engine does not need to deliver more power to increase the speed because that speed is maintained same by the car. So we can write as speed remains constant, car engine needs to deliver less power and hence current decreases. Next, the question says state the principle of superposition. So the principle of superposition states that when two or more waves overlap each other, their resultant displacement is the sum of their individual displacements. Question B, it says light of wavelength 7.2 into 10 raised to minus 7 meter, that's lambda, is incident normally on a double slit as shown in figure. A screen is at distance d from the double slit. The double slit and the screen are parallel to each other. The separation of the slits in the double slit arrangement is 0.16 millimeter. So this is small d. The resulting interference pattern on the screen contains 9 dark fringes as shown in figure. Now, from the first fringe till the 9th fringe, the distance is 3.2 centimeter. Now, the fringe width is measured from center of one fringe to the center of another fringe. So you can understand from this point to this point, we will consider it as one fringe. Okay. So like that, there are 8 fringes over here. Okay, and between these 8 fringes, the total distance given is 3.2 centimeter. So we can quickly calculate the fringe width over here, that is 3.2 divided by 8, that is 0.4 centimeter. The question is, the distance between the centers of the first and 9th dark fringe is 3.2 centimeter. Calculate D. So we know the formula for fringe width. It is x is equal to lambda d upon small d, where capital D is the distance between the slits and the screen, and small d is the distance between the two slits. So x, as we already calculated, we will also show it here in the calculation. It is 3.2 divided by 8, 0.4 centimeter. So capital D will be equal to x into d upon lambda. So x is 0.4 centimeter. So we have to convert that and write it in meter. Small d is also in millimeter. So it will be 0.16 into 10 raised to minus 3, and then wavelength, which is 7.2 into 10 raised to minus 7. The answer comes 0.88. So we can write it as 0.90 meter. Next question, the slit separation is now gradually decreased from 0.16 millimeter to 0.04 millimeter. The distance between the centers of adjacent dark fringes is x. On figure 4.3, sketch the variation of x with the slit separation. Now what is the relation between the slit separation and the fringe width? See, it is x is equal to lambda d upon small d. So x is inversely proportional to the slit separation. So as the slit separation will decrease, the fringe width will increase in the same ratio. Okay. So initially the fringe width is 0.4 when the slit separation is 0.16 mm. So my first point will be here. When you will decrease the slit separation from 0.16 to 0.08, that is, you will make it half, the fringe width will be doubled. So the second point will be here, and when you will make the slit separation 1/4, that is 0.04, the fringe width will be multiplied by 4 and that will be 1.6 here. And so your graph is going to be a curve like this. Okay, next question. Question number 5, it says use the definition of speed, frequency and wavelength to derive the wave equation. Now what is the formula for speed? It is distance upon time. Now in case of waves, the distance is the wavelength. So we can write this as wavelength upon time. Note that we are calculating speed for one wave and that's why we are taking distance covered by one wave, which is wavelength. So we can write it as lambda divided by t. Again, the time taken by one wave is called as time period. So I am writing it as capital T. This will be lambda into 1 upon t, and we know that 1 divided by t is frequency. So this will be lambda into f, and that proves V is equal to f lambda. Okay. Question B. A source of sound waves of frequency 236 Hz is traveling at constant velocity of 20 meter per second. This is the velocity of the source. A stationary observer has microphone connected to a cathode ray oscilloscope. The microphone detects the sound wave as the source moves directly towards the observer. The resulting trace on the CRO is shown in the figure 5.1. Note that the source is moving towards the observer, so the observed frequency is going to be greater than the actual frequency. Okay, and this is the actual frequency of the source. So let us write it as Fs. The time-based setting on the CRO is 1 millisecond per division. Okay, so you can see this is one division which is of 5 boxes. Calculate the frequency of the sound wave detected by the microphone. So the setting on the CRO is 1 millisecond per division. Okay, and you can see for one wavelength how many divisions are considered here. So these are 4 divisions. Okay, so we can write this way: one wavelength is 4 divisions. Okay, so one wave takes how many milliseconds? 4 milliseconds. Okay, now this 4 milliseconds is the time period of the wave. So we know F is equal to 1 upon t, so we can write it as 1 divided by 0.004 . This comes as 250. Okay, now this frequency is the observed frequency. Now determine the speed of the sound in air. According to Doppler's effect, when the object is moving or the source is moving towards the stationary object, the formula for observed frequency is F equals to frequency of the source multiplied by velocity of the sound in that medium divided by velocity of the sound in that medium minus velocity of source. So the substitutions would be 250 is equal to 236 V upon V minus 20. So we can write this way, 250 in bracket V minus 20 is equal to 236 V. So 250 V minus 236 V is equal to 5000, and then V will be 5000 upon 14. This comes 357.1. We can write this as 360 milliseconds. Question number 6. It says a nichrome wire X of length 45 centimeter and area of cross section 4.7 into 10 raised to minus 7 meter square is connected into the circuit as shown. The resistance of X is 1.1 ohms. The cell has EMF of 1.3 volt and negligible internal resistance. Calculate the current in X. In the circuit you can see there is only one wire. Okay, so to calculate current we can simply use formula V divided by R, where V will be 1.3 divided by the resistance of that single wire is 1.1. So 1.3 upon 1.1, this gives answer 1.18. So we can write it as 1.2 ampere. The number density of charge carriers in nichrome is 8.5 into 10 raised to 28 meter cube. This is number density indicated by letter N. Calculate the average drift speed of the charge carriers in X. So we know the formula for I, it is NAVQ. So V will be equal to I upon NAQ. Note that I is current, N is number density, A is area of cross section of the wire, and Q is elementary charge. Substituting all the values, we can write 1.2 divided by number density first, that is 8.5 into 10 raised to 28, area that's 4.7 into 10 raised to minus 7, and then elementary charge value, that's 1.6 into 10 raised to minus 19 coulomb. The answer here in the standard form is 1.87 into 10 raised to minus 4. So we can write it as 1.9 into 10 raised to minus 4 meter per second. The next question is calculate resistivity of the nichrome. The formula for resistivity is rho is equal to Ra upon L. The answer for resistance, the value for resistance is 1.1. The area is 4.7 into 10 raised to minus 7 upon the length, that is 45 centimeter, 0.45 meter. This is 1.14 into 10 raised to minus 6. So we can write 1.1 into 10 raised to minus 6 as the resistivity. Next, wire Y is identical to wire X. Wire Y is added to the circuit in parallel with wire X as shown in figure. State and explain the effect, if any, of this change on the reading on the ammeter. Now note that the second wire that we have added in parallel with the first wire is going to reduce the overall resistance of the circuit. When two or more resistors are connected in parallel, the overall resistance of the circuit decreases. So, since the resistance decreases, the current is going to increase. So, we can write in parallel total resistance of the circuit decreases, hence current increases, ammeter reading increases. The next question is the average drift speed of the charge carriers in X. Note that here they are asking only for X, not for Y. Now, the average drift speed is given as V is equal to I upon NAQ. Now, if you see particularly for wire X, the current in wire X is going to be V upon R. So, see, neither voltage of wire X is changing. It is 1.3 as it was earlier. The resistance of the wire remains same, that is 1.1 ohms. The other things, that is number density, cross-sectional area and the elementary charge value will also remain same, and that's why even though total current of the circuit is increasing, the current going in wire X is still constant, and so the average drift velocity will also remain constant. So we can write here that current in wire X is unchanged, hence average drift velocity of charge carriers remains constant. It doesn't change. Next, question number 7. It says that nitrogen 12 is an unstable isotope of nitrogen that decays by the emission of radiation to carbon 12. Complete the full nuclear equation for the decay, including all the particles involved. Now you can see here that from the parent nucleus, that is nitrogen, which has proton number 7, the daughter nucleus, that is carbon, has proton number 1 less, that is 6. The proton number decreases in beta positive decay. So here the beta decay is beta positive. So we can write it as C612 plus beta positive. Here we will write 1 and 0 plus in the beta positive decay, that is positron decay, we have one more particle coming, that is neutrino. So we will write it as neutrino, which has almost negligible charge and negligible mass. Question B, it says hydrogen 1 is an isotope of hydrogen. An atom of hydrogen 1 comprises a proton with an orbiting electron. An antiparticle equivalent of hydrogen 1 comprises an antiproton with an orbiting positron. The antiquarks in the antiproton are the antiparticles of the quarks in the proton. Thus, state the charge on the positron in terms of elementary charge E. So, positron is positively charged particle. So, like electron has -1 charge, the positron will have +1 elementary charge. So, it will be +1. Next, state the group of fundamental particles to which the positron belongs. So, positron belongs to the same class of particles as electrons. So, it is leptons. So, the answer here will be leptons. The next question is, in table 7.1, state the flavor and the charge of 3 antiquarks that comprises the antiproton. So, see, proton has combination as up, up, down, okay, and the charge combination is plus 2 by 3, plus 2 by 3 and minus 1 by 3, that gives us total as plus 1. This is for proton. Now for antiproton, the particles are going to be antiparticles of these quarks. So this will be anti-up, anti-up and anti-down. So the charge here will be minus 2 by 3, minus 2 by 3 and plus 1 by 3. So if you see, minus 2 by 3, minus 2 by 3 plus 1 by 3 gives minus 3 by 3, and that gives you the total charge of minus 1 times of elementary charge. That sums up our paper. See you in the next video, wherein we are going to solve the second variant of the same series, May-June 2025. Thank you.